similar triangles. Let me get my coffee. I can't teach without coffee. All right, so today there's going to be two sets of triangles. And our job is going to be to figure out if they are similar or not. And then if they are, they may ask me to find certain angles, length of the sides, so on and so forth. First, we need to know what similar triangles are. Similar triangles must have two angles that are congruent. Put a big star by it, put it in the notes. If we can prove that two of the angles are congruent, then I can say these two triangles are, in fact, similar. So let's start with a 90 here, a 90 here. Can I say that they are congruent or they are similar yet? No. We only know that one of their angles is the same. So if I can prove that angle's the same as that, or that angle's the same as that, then we're in business. Are you with me? What if we put 30 degrees here and 60 degrees here? What can we do to prove if they are similar? Layla, what do you think?
Add 90 and 30.
What's 90 plus 30?
120.
And then what do we do?
Subtract it by 180.
To see what this other angle is? What's 180 minus 20?
60.
Can I now say that these two triangles are similar?
Yes.
Prove it. Who can prove it? Lizzie.
One of the top angles is 60 degrees and one of the side angles is 90 degrees.
Good. The rule over there says they must have two angles that are congruent. Are these angles congruent? There's one. Are these angles congruent? There's two. Are you with me? By the way, what's this third angle?
30 degrees.
Why does the rule only say two angles? Not three.
I say because you could just find the last angle by subtracting.
Yeah, but why does it say we only need two instead of all three? Because we found out all three of these angles are really the same. But the rule only says two.
Because they're similar, not like equal.
Yeah, but why do we need two of the three instead of all three? Because I would have thought we need all three angles to be the same. Because in fact, all three angles do have to be the same, but the rule only says two.
Because it says similar, not the same.
Nope. Well, if this one's 60 and this one's 90, this one's 60 and this one's 90, are you with me? And we do a little math, what will the third one always be? 30 and 30. So in fact, if we have two angles that are the same, don't we really have all three angles that are the same? Hello?
Yeah.
We don't need all three. We just need two of them to be the same. Then the third one will have to be the same as well. Does that make sense? Because the math doesn't lie. If that's 90 and that's 60, that's 150. The only thing left for this one would be 30 after you subtract. If this one's 90 and 60, since they're both 180, once I do the math and subtract, this one has to be 30. So the rule says we only need two. But in fact, if we have two, then we really have all three of them are really the same. Does that make sense? Okay. But you only need two of them to prove that they're the same. All right, so there may be some problems like that, or they just have, or ask you to tell if they are similar or not. What if we do this? Nope. I don't want that there. What if they give me this picture and ask me if these two triangles are similar? Somebody tell me what we can do. Besides Lizzie, she's already helped me. Thank you, though. Gabby, what are you thinking?
I mean, each triangle has to equal 180.
Correct.
70 plus 40.
What's 70 plus 40?
110.
Then what do you want to do with the 110?
Subtract it by 180.
What's 180 minus 110?
170.
What?
Oh, 70.
70.
Sorry.
So this angle up here is 70. Are these two triangles going to be similar?
No.
Nope. Because don't they both have 40 in the corner? The big triangle has 40 in the corner. The little triangle has 40 in the corner. So they got that angle that's the same. But if this one's 70, are you with me? The math makes that one 70, because 70 plus 70 plus 40 is 180. Let's do a little math over here. What's 80 plus 40? 120. And what's 180 minus 120? What's left in this corner? So these two triangles would not be similar because two of their three angles are not the same. Does that make sense? All right. Let's do another problem. Let's say we have this triangle. And they tell us they are similar. And they put some numbers on the sides. Actually, I'm going to move this one. You don't mind? Let's do this. Let's make this from here to here 20. And from here to here 4. There we go. All right, so they've already told me they are similar. We don't need to find the angles to prove that they are similar. They told us it is similar. All right. Anytime you have two similar triangles, their side lengths become what we call a proportion. Are you with me? Here's what a proportion is. Are these two fractions equal? Yes or no?
Yes.
Does 1/2 really equal 3/6? Isn't this one just bigger? But it's the same, it reduces down to 1/2. Are you with me? So anytime we have similar figures, there is a proportion that is made. This big one is really the same fraction as the little one. It's just maybe multiplied by a number, like 2 or 3 or 4 or 5, whatever. So anytime you have similar figure or similar triangles, you can set up a proportion using the numbers that they give me. Are you with me? And here's the one I always find first. Do you notice how they give me the bottom of the big one is 20? And the bottom of the little one is 4. That's the one I always use first. Are you with me? And you can do 20 over 4, or you can do 4 over 20. It really doesn't matter. Keandra, you want to put big on top or little number on top? You pick.
Big on top.
Big on top. All right, so we're going to put 20 up here, and we're going to put 4 here. Always use the fraction that they give you two numbers for first. So I'm going to label this big is on top, little's on the bottom. Sweet. They give me another number, 15. Lestat, is 15 part of the big triangle or the little triangle? It's the big one, so where does the 15 have to go? Bottom? We put big on the bottom? It's got to go on the top. If you put big on the top, then you better put big on the top. What number do I need to find?
X.
Which is the
Little.
little, so X goes on the
Bottom.
bottom. Any questions on how to set up the proportion? Question. All right, once you got the proportion set up, what do we do?
Bat and ball.
I've never heard of bat and ball. I've heard of butterfly. Cross multiply. I don't know what Stavlo teaches, but I've heard bat and ball. So y'all do bat and ball. Here's what it really is. You multiply this number times this number. What's 20 times X?
20x.
Then you make it equal to the other number times the other number. What's 15 times 4? 60. Are you with me? And now what do we do? Divide by what?
60 divided by
We're dividing by 20 because we're trying to get X by itself. So divide by 20, divide by 20. And what number should X equal?
3.
This little number right here should be 3. Questions? So you can use the proportion. Y'all can do the bat and ball stuff if you understand it. I don't understand it. I've never seen it. I just cross multiply. That times that equals that times that. Now you got a one-step equation. Divide by 20 and we're done. Questions? All right, what if we have one like this? And almost all of your proportions are going to be big and little. Let's say that these two triangles are similar, and we need to find out how long X is. I made the numbers wrong. Doesn't the little one have a bigger number?
Mm-hmm.
Oh well, we'll just go with it.
Okay.
All right, I need a fraction. Who can give me a fraction?
8 over 9, or 9 over 8.
Make up your mind.
9 over 8.
Okay, she wants to use 9 over 8. Didn't you give me two numbers from the big one? Okay, that's fine. So we're going to go big over here and little over here. She's going this way. So 8 over 9 is what she said. Now, where is 8? Tell me where 8's location is.
Small.
No.
On top.
It's on the, no, it ain't on top. You need to know where each number goes. 8 is the number on the bottom of this triangle, people. By the way, I never personally use the same numbers from the same triangle. It seems like kids get confused. I always take a big one and a little one. Are you with me? I personally would have done 14 and 8 because that's one number from the little and one number from the big. But this will work. It's just a little more confusing because we're putting all the big ones here. So now we really need to label it top, bottom, and what is this? That ain't the top. The top's up here. What side? The right side. Thank you. We're going bottom and right. So we really don't even need big and little. We're going to go bottom and right. All right. What number do I need to put here? Ethan. 14. It's the little triangle's bottom number, 14. What number has to go here, Alina?
X.
Yes, ma'am. Okay, questions? Okay. Now, I definitely wouldn't have done 8 over 9. I would have done 9/8 because that's the way they're sitting in the problem. Does that make sense? But you can set it, there's actually 4 different ways you can set up the proportion. And all of them will give you the same correct answers. All right, so let's do the bat and ball, whatever. What's 8 times x? 8x. What's 9 times 14?
36.
Try again.
126.
126. And then if we divide by 8, what do we get?
15.75.
We get a decimal on this one? 15.75? That's fine. It is okay to get a decimal every now and then. 15.75. Questions? All right. I think you're ready for the assignment.